and our expert teams are so excited to share with you the unique way in which Defiant will help you in your conditioning monitoring systems. Thank you guys for joining.
Defiant addresses several key challenges in machinery monitoring and asset protection, reducing unplanned downtime by detecting abnormal changes in vibration and other parameters in real time. It helps predict failures and avoid unexpected shutdowns. These insights support data-driven decisions and enhance predictive maintenance strategies. Overall, Defiant offers immediate, streamlined information for operators while also providing sophisticated analysis features for specialists, making it a comprehensive solution across different organizational levels.
Hello, everyone, and welcome to the Defiant Masterclass from the Masters of Machine Health, Erbessd Instruments. My name is Dave Howard. I'm the CEO of Erbessd Instruments, and we are incredibly proud to present to you and the rest of the condition monitoring industry the Defiant. The Defiant is an exceptionally innovative product that has taken us 2 years of hard work and dedication on the part of the entire team around the world to develop. And what Defiant is beyond just what we see. So, physically everyone could see in the photo that Defiant is a hardwired interface. So yes, it is an 8 or 16 channel continuous monitoring system, but it's also a protection system, and that opens up new doors within the Erbessd Instruments ecosystem. So as a protection system, it makes us API 670 compliant from a shutdown perspective. And that is something that has been missed within our portfolio of products for the past 10 years. So we're very proud to bring the protection class device to our ecosystem. In addition to that, one of the things that makes Defiant a unique product is that it has both Ethernet and Wi-Fi capability, and that capability makes communication something that's quite simple and quite easy to integrate within the industrial environment now. In addition to that, one of the amazing elements, and it was a key criteria from a design perspective, was onboard storage. So the Defiant has an onboard solid state hard drive, and that solid state hard drive can, in a circular buffer, which we will discuss later, record data for days. So it's an incredible new tool from a commissioning and troubleshooting perspective. And it also, of course, because it is a protection system in addition to a monitoring system, it has relay outputs to trip a machine and shut down a machine. That's something that has been missing within the portfolio of products for us for quite some time. So it's, again, a very, very unique element within the Erbessd platform. Lastly, like everything else that we've done within our portfolio of products, is the Defiant seamlessly integrates within the entire Phantom, Digivibe, and the rest of the ecosystem of condition monitoring and IIoT products within the Erbessd Instruments platform. But really, at the end of the day, why did we choose the name Defiant? And I'll just touch on that briefly. If we talk about Defiant and what it is and why we chose that, it's because Defiant will defy the rules within the industry in terms of the status quo, the norm of what we've begun and what we've grown accustomed to expect from hardware device manufacturers. So not only does it do all of these things, but what else can Defiant do? Well, Defiant also combines wired, analog, and digital inputs with wireless signals. So the Defiant has essentially the embedded IIoT gateway infrastructure that we've all grown accustomed to within the Phantom gateway that we see here. So at the end of the day, that user interface, that experience, that configuration profile, all of those things are very familiar, and we'll see that combining wired and wireless signals from a process monitoring and a condition monitoring perspective, gives us a very unique capability that we've not had before. Being able to monitor our critical assets using the wired channels, but then also being able to monitor the balance of plant, the ancillary or the auxiliary assets like the boiler feed water pumps and things like that. Those are things that are also incredibly important, though they might not lend themselves well to a continuous protection monitoring system. So we're combining the best of both worlds with Defiant and defying the rules by combining both protection and condition monitoring surveillance of assets using wireless sensors. That's a very unique feature. As I said, it's both protection hardwired and a monitoring system using those. One of the things that's really unique about Defiant, and we'll get into that in just a moment, is the fact that it's both a machine health monitoring system, but also a process monitoring system. And as a former reliability engineer, one of the things that used to really make my job difficult was I would be reviewing all of the vibration and reliability machine health information data within the Digivibe platform, but then in order to correlate that to process data, I found it very difficult because I would oftentimes find myself going to OSI Pi or iHistorian or a tool similar to see what the process was doing while at the same time reviewing the asset health data. And now with Defiant, we're combining that because by combining the signals of not just the condition monitoring aspects and the machine health aspects, but now adding the ability to combine process data so that we can do true correlational analysis with the process. That opens up a whole new dialogue between our process and operations partners and the maintenance teams. So seriously, when we think about a defining characteristic, bringing process data and condition monitoring data into one platform is something that has been long needed within the maintenance and reliability communities. Another defining characteristic of Defiant is the fact that there are, as a standalone system, it has its own onboard analytical software suite using the embedded Wiser Vibe application. And that's going to continue to grow just like Wiser Vibe, just like EI Analytic, and just like the rest of our software applications. So it's truly an incredibly defining product for us. It's truly an incredibly defiant product within the industry because we're combining all of these variables to be able to analyze data in ways that we've never been able to analyze before. So again, we're incredibly proud. Thank you for joining us for this masterclass. We hope that you find it to be very useful. And we hope that you find that Defiant is a product that you've been waiting for. So with that, I would like to just add what we additionally have added, I apologize, is just like the gateway has the embedded MQTT, OPC UA, and Modbus TCP IP and REST API functionality so that we can take that data and incorporate it within third-party systems. The Defiant has that same functionality. So now, not only are we able to combine process data, combine machine health data, but and review that data within the Erbessd Instruments platform, software platform for analysis purposes, but we can also parse that data to third-party solutions using these industrial communication protocols. So again, thank you so much for joining. And with that, I'm going to turn this portion of the presentation over to our Director of Development, Juan Pablo Mendoza. So thank you, Pablo. You're up, sir.
Hear me? Okay. Hello, everyone. Can you hear me now? Hopefully. I'm Pablo Mendoza, Director of Development, and I cannot turn on my mic to speak. I'm very glad to be here to see so many people interested in the Erbessd Instrument product. As David says, this is a product that we have been working now for a couple of years. So I'm really excited. I'm really glad to finally be able to present to everyone. You're seeing in my screen now the interface for Defiant. So the interface for Defiant is web-based, it's browser-based. That means that you can, once you have plugged this to your Wi-Fi network or to your Ethernet cable, you get into your computer and this is what you see in a browser.
Just a second, Pablo. Sorry, I believe we can't see your screen. Are you maybe presenting your...
Sorry, let me try again. Can you see it now?
Yes, there you go. Thank you.
Okay, so this is what you see. Now you guys can see it. This is what you see when you log in into your Defiant. You can see your Defiant while you're in the same network as the Defiant, obviously, but you can also see it anywhere in the world using our A-Analytic Cloud solution. It will give you remote access to your Defiant from anywhere in the world. Or you can also see it using like your own means, like a VPN or whatever the organization has set up. You can use that to see it remotely. So this is a online system. It's meant for permanent installation. You go install it somewhere, leave it there, and then you use it remotely. All right. For those of you that are already familiar with a Phantom wireless or Phantom family of wireless sensors, this interface looks very familiar because it's actually based on the same software and the same concepts. And actually, Defiant has complete support for wireless sensors. So the sensors that I'm seeing here, all these little cards here, are wireless sensors that the Defiant is seeing. So the Defiant can see wireless, Bluetooth, Phantom sensor, and it can use them to take recordings, use all the technologies that are familiar to you guys, like Phantom Sync. All of that works in Defiant. It retains all of the functionality of the Phantom lines of sensor. But what we added now is the hardwired sensor. So we have a version for 8 channels and a version for 16 channels. So you get to this part of the interface and you see we have one card for each one of the channels of Defiant. And the first thing you have to do when you set this up is tell the system what you want to plug into each channel. Defiant has a large amounts of sensors that you can set up, all kind of different sensors. The first one and the one that we are more familiar with is the accelerometer. You can plug your standard 2-pin accelerometer into a Defiant channel, set up the sensitivity, and it will just work. So I'm gonna do that. And you see that the channel already start working. What else can I plug into my Defiant? So I can hook up a displacement sensor. So a proximity probe, you can put in here a laser displacement sensor, any kind of displacement sensor that is given a voltage output, you can hook up to your Defiant. And you will get the appropriate options for that. You can also set it up as a pulse strain output sensor. This is something like a key phaser that gives you a square wave output for each revolution of your motor. So this will be good to know the speed of a motor, to be able to correlate that square wave to a time waveform graph from a vibration sensor, so you know the phase of the vibration time waveform at any point. So you can hook up that kind of sensor. You can also, I say key phaser, but you can also get a cheap Hall effect sensor, put a magnet somewhere in a fan or something, and you can get the same square wave output and use that. The other thing you can hook up is a discrete voltage sensor. So this is mean for things that are, so all of the previous things that I was talking about are dynamic signals, things that are changing very rapidly over time, and you want to see a time waveform. But you can also hook up a sensor that gives a voltage output, such a temperature sensor that gives you a single value out. So if you only want to know the temperature, you can put that in there, and it will give you a voltage output. And we have several ranges that we support. We support 0 to 5 volts, 0 to 10 volts, and 0 to 12 volts. So, and this, if I enable that, you will see that it gives me a single value out. And it has a bunch of options, like if you want, you might see that this value is jumping a lot up and down, but I can enable a moving average, so I can average the last n values. So there is that. Let me set up a bunch of other channels.
Pablo, we've just had a question in the chat from a couple of people. Do you mind just explaining to us what our new limits are with lines of resolution and Fmax with the Defiant, please?
Yes, sure. So the Fmax sample rate will be 32 kilohertz per second, or you can change that to 64 kilohertz per second. So the Fmax will be at maximum will be 25 kilohertz. The lines of resolution, I want to talk a little bit about that a little bit further down. So let's say that the lines of resolution will be unlimited. But we will talk a little bit about that as we go on. So already I have set up some channels here. You can see that I immediately start seeing all these overalls. So I'm seeing here velocity RMS, acceleration RMS, acceleration envelope, a bunch of bands here, and we actually can enable or disable some of these. I even get a cute little octa bands display in here. So the Defiant is already gating the data, and it's calculating these overalls as fast as it can. It's calculating them in real time, right? So let me come here, and I can actually show you the time waveform and the FFT being grabbed in real time. So, oops, let me scroll down a little bit. So you can see that it can show me the waveform and the FFT in real time. And I can actually pause that. And for those of you who are familiar with the Erbessd ecosystem, will recognize this as the analysis screen on the YSurvive app and A Analytic. So that now is embedded into Defiant. So you don't really need anything else to do your analysis. This is built into Defiant and can be used if you so wish to do so. You can use it completely offline. You don't need anything else. and it has all the analysis tools that you're familiar with and that you might need. It has all the markers and I don't know, everything that you can think of, you have it in here. So we are leveraging all of the development that we already did for our apps, and we put it inside the Defiant. You have circular time waveforms. You have this one. Let me go back there. There you go. You got your circular time waveform. You got orbits. You got auto diagnostic. You got everything you can think for analysis. You got in there, right? So it's it's a very powerful solution because everything is embedded in build right in. Okay. Okay, let me talk about a little bit about power. How do you power your sensors? So the most common sensor that we expect people to plug into the Defiant is your standard 100 millivolts per G accelerometer, 2-pin accelerometer that needs 20 volts power. So that's built in the Defiant. You only have to come here, enable an option, set that. You get a little warning that that's going to send 20 volts to your sensor. So be sure that your sensor needs 20 volt. Once you okay that, the sensor should be getting the 20 volts. Let me see. And you get a little power enable thing here at the top. For our sensors, we are providing a 5 volts and a 12 volt power in the Defiant front borns. So you can grab the power from there. It won't be automatically. You will have to wire that to your sensor, but the options are there, so you don't have to go for a different power option, right? You can grab it right there from the device itself. All right, so let me show. So once you have enabled, you're already getting your overalls here, right? But you want this to be getting data where you're not looking at it, right? So we have the configuration here where you can tell the device what kind of data you want it to record. So you have to give it a name to it, and then you have 3 options. You can record data on an interval, on a time of the day, or based on a channel parameter. So for an interval, you say, well, I want to get data every hour. And every hour, I want to collect channels 1, 2, 3, maybe those 3 channels are a single triaxial accelerometer, and 4, 6, and 7, maybe those are a different triaxial. So I select which channel I want to record. I choose my lines of resolutions, and then I have to choose what I want to do with the data. The data I can store locally on the device, so the data will be on the Defiant SSD, and I can actually choose to send it to the cloud or to a analytic or cloud solution analytic, or to a monitor, or to MQTT, right? So I can do that on an interval. I can do the same thing on certain times of the day. So I can say, well, at 1 o'clock, let's do a collection. Let's do another at 3 o'clock. And then let's do another one at 6 p.m. 05. And I can add as many as I want to, right? And then the other one, and the most powerful, is that you can do a collection based on a channel parameter. So let's say I can say when the channel 4 acceleration envelope is greater than 8, and this condition has been held during, let's say, 20 seconds, because I want to eliminate transient events, I want to collect all of these channels. And then I'm going to send that to Analytics so I can have notifications. So you set this up, and you can set up as many as you want. And we think it's really powerful because this is being checked like 50 times a second. It's being checked in real time, so you will get an instantaneous response, and you can get an instantaneous notification when something is wrong. And also, the other thing that I wanted to mention is that Defiant has some digital channels. In addition to the 16 analog channels, it has 4 digital channels. Each one of those channels can be an output or an input. When they are set up as an input, they are dry contact inputs, also known as relay inputs or PLC inputs. And you can use those as well to trigger a recording. So you can say when the digital channel 1 is open during 20 seconds, take a recording. So you can use that to trigger collections from a PLC or some other programmatic way to trigger collection outside of the Defiant based on process variables or something like that, right? And if you send the data to Analytics, you will be able to analyze there and to look at it there. But if you choose to use store locally, again, you can come here and see all the list of files that you have collected. Let me see. You can see all the list of files. Let's wait for that to load. There you go. So you can see the files that have been collected that are on the device. And then you can come and add as many as you want. I already have 5 files in there. Basically, there is no limit to the waveforms that you can superimpose in here. And again, you have the full blown analytic power that we have been working for the past 5 years. So you have the whole Weiserby tools. You got Orbit, you got circular FFT, you have markers. I don't know, everything you can think of, enveloping, big view, everything you got in here, right? So it's really powerful. Okay, so earlier where somebody was asking about what the lines of resolution is, I said there were infinite. But if I come here, there is a limit of the lines of resolution, right? There is no more options here. But what I can do is, if I go to my channel configuration, we have this option here that says store data continuously. What this option does is it commands the Defiant to store the data, all of the data that is reading. So it can store, if you enable all 16 channels, it has the storage to save about 2 days of data. So you can have a 2-day length time waveform, no samples missing, everything will be in there. So in that sense, that's why I say that the lines of resolutions are infinite. How would you view such data? How can you view so much data? You cannot make a FFT that big, of course. So what we do is you come back here. Let's wait for that to load. Refresh. So what we do is when you come here, this recording that I'm seeing here is, I think it's like 9 hours of data. So what you see is at the bottom, you see this summary, if you will, of the time waveform. And I can zoom in on it. And it's showing me the seconds. So this is the first 50 seconds, 60 seconds, 70 seconds. And I can click on it. And I can see a portion of the waveform. So I can see windows, little windows of the data. And I can zoom on it and I see some transient event that I can identify. I want to dig further. I can just click on it and it will display the time waveform. And how much data can I see at the same time? It depends on how much memory you have on your computer, but let's say you can see like 20 seconds or terabytes of data. But you can keep moving over it. So with this, you can grab, well, obviously you can grab continuously just to monitor transient events, or you can record the whole starting and stopping of a big machine if you want to analyze that. So this is, we think it's very powerful. This functionality, you will be able to see basically nothing missing. You won't miss anything about your machine. So this is very interesting for very critical assets, right? And again, this has the full power of the Erbessd analysis tools built in right into the device, so you don't need anything else. The other thing that I wanted to show very quickly is the digital channel. So I showed you earlier that you can trigger recording of those digital channels, but you can also set up the channels as outputs. When they are set up as outputs, they give, when they are off, they give a 0 volts output, and when they are on, they give a 12 volt output. The idea with this is that you can hook this output to a relay that will trigger a contactor that can shut down a machine, or you can turn on some kind of alarm, or you can hook it up to a PLC that will, I don't know, lower the motor resolution if vibrating too much, I don't know. So you will come here and tell what do you want to use the channel for. If you want to set it up for output, then you want to say that the channel is normally disabled, and then based on channel 2, velocity RMS is greater than 10. I want to enable the output. And then I can hook that channel to a alarm, some sort of visual or audible alarm. And every time that the velocity RMS of channel 2 goes about 10 millimeters per second, it will turn out the alarm, and you can hear that, right? So it's And of course, there are many more applications for this. And we're missing some options here. I'm going to talk about that a little bit further, but we are missing some options here that we like hysteresis and something like that. But I want to talk about that a little bit ahead. Okay, just quickly show you the analytic integration. We have simplified that a little bit. Now it's more integrated into the device. It's very easy to just come here and say, if you want to send the data to analytic, the Defiant will be sync down your analytic data, and you can come here and choose which machine and which point and which axis you want to send the data to. So you set that up very quickly. That's already assigned now. And now every time one of your recordings triggers and you have choose to send the data to analytic, it will go straight to the machine that you choose here. And you can start very easily if you want. You can change that very easily if you want to. All right, and the very last thing that I want to show you is why. And you might be wondering what good is to be updating all these overalls like this quickly. Like I can't even see it, right? Like they're changing so quickly that a human cannot make sense of them. Like this one that is jumping back and forth, right? So what is that useful for? Well, remember, we're one of the vibration companies that has more open data than anyone else. Every bit of data that we produce has APIs, has hookups to be able to use it, and Defiant is no different. So we support Modbus TCP, we will support Modbus RTU, OPC UA, MQTT, REST APIs, everything you can think of to get this data. So let me very quickly show you the Modbus setup. You can enable the Defiant Modbus server, and you can export the data from wireless sensor or wired sensor. With wireless, it was more useful for trending and sending the data to a data lake so you can have trends over weeks and months. But now when Defiant is now truly useful for automation, because every value in there is being updated in real time. So you can hook this up to your PLC network, and you can stop machines that are getting out of hand. You can stop a pump that is being blocked or that is running dry. You can, I don't know, whatever the customer wants to do, they can do it. They can build HDMIs that can display all these values.
Just a question. Sorry, Pablo. Are we going to be adding octave bands to this?
Yes, octave bands are actually already enabled. You can see the bands in here.
We had a question about alarming misalignment, unbalance, and those kind of things. Will we be adding octave band alarms to the digital outputs?
Yes, you will be. I don't think it's here right now. I don't think it's there right now, but we will definitely add them to the list. You can be able to choose any of the bands in acceleration, velocity, and acceleration envelope. Any of the bands you will be able to choose for the digital channel output, for the data collection triggers. The data is already here. You can see the bands here. We are drawing them here at the bottom of the card. So yes, you will be able to use that certainly. Let me check. Do I have anything else? I think that's everything else I want to show for today. I'm gonna start sharing, guys. I have one extra slide that I want to show. You can put the slides back in.
Oh,
It's the platform for the future. There you go. So that one. So I just wanted to talk about this. So I just show you guys a bunch of functionality. That's the functionality we will have when the device is launched. But this, for us, this is not something. So this device is not something we contracted out and somebody did it for us. This is not something we are white labeling from somebody else. This is a product that the team here at Erbessd Instruments and all over the world built from the ground up. Every transistor, every resistor, every component was chosen by us. All of the software is written by us. So we are the experts on this. For us, this is a platform that we will build on the future. Just as we have been building with Phantom, we will build on the Defiant, and we will add more features as the time goes on. Some of the features that we will add, I don't think we have talked about them now. Some of the things we are thinking about adding is very fast sampling for ultrasonic sensors, maybe multiplexing the channels. Of course, more integration between wire and wireless sensor, like triggering a wireless sensor based on the data of a wire sensor. I don't know, there are so many things that we want to add in here, and we will be adding that in the future. So be sure your investment will be keep on giving. This is something we will keep working on the future.
yeah, I mean,
That's it.
one of the things to consider here for everyone on the call is the fact that Defiant, as Pablo has pointed out, is truly a platform built for the future. And as we continue to develop it, it's going to be based very strongly on the input from the field. So if there's something that isn't available in the initial launch and it has a very significant use case, please let us know. And with that, we're going to move on to Oliver Modershead. Oliver is our managing director for Erbessd Instruments Europe. So Ollie, I'm going to run the slides for you. You just tell me when you need next slides.
I can present if you want.
Oh, there you go.
I'm good to go. So yeah, hello everyone. I'm Oliver, Managing Director for Erbessd Instruments Europe. One of the things that I really wanted to go through in my section of this call was about how are we actually going to use this device and how is that going to look in the field. So Pablo sort of told us about some of the functionality, some of the features, but now I really want to get into what are the use cases or the potential use cases that we can see for the device. There's hundreds, maybe thousands of different applications, but I just want to use some examples of where I can really see this being useful. So if we just take compressors as an example, it's not necessarily just about the compressor anymore. It's about the entire compressor systems. You know, we're taking wired data. We've also got the capability of wireless, so we can use those other phantom sensors to add to that. So whether that's the intercooler, whether that's thermography using the thermal camera inside a control panel, whether that's oil condition sensors within the oil separation and scrubbers. So just using that, typical faults of a compressor. The very first one that gets complained about is that there's no output, no delivery. So we can use things like pressure sensors to say input and output pressure. What is the efficiency of this? We can start trending that. So I think there was a question about that in the chat earlier. There are trending capabilities on the Defiant as well. There are some things. Compressors overheating, knocking, the usual sort of vibration problems, high vibration. We've also got oil consumption. So whether it be levels, whether we monitor the levels within that, or I briefly mentioned oil condition. Maybe we look at contamination within that oil using a resistance sensor within that sits in the bottom of the sump of an engine, for example. And what we're looking at, so vibration, oil, inlet, outlet pressures, but with those digital inputs and the additional inputs that we've got with Defiant, we can get more measurements from PLCs, like load, like speed. So when we're on full load, we're going to get high vibration, but that's something that we may have missed if we hadn't have had that parameter trended along with the vibration. So that's just to give you a quick idea of where we could use it, where we could use these extra sensors. Wind turbines is another great one where we feel that this is going to have quite a lot of success, because if we look at stereotypical wind turbine faults, it's gearbox failures. We can do vibration, we can do oil condition sensors, we can look at the amount of wear metal within a gearbox. Generator issues. So we are looking at motor current analysis. Well, we are going to be doing motor current analysis, whether that's basically time waveforms through CTs. Pablo knows more about that than I do. We are going to be looking at like blade damage, bearing wear, electrical system failure. Yaw and pitch on motors is a very common issue on wind turbines again, and that's something where motor current analysis will come in. Structural, now that we've got these extra parameters, we can start taking in strain gauges. So looking at the base and the top and how much strain is within the structure. Inputs from the PLC. I think there was another comment about, is this a miniature PLC? It is bordering on a micro PLC. There are a few things that we're not doing that a PLC can do, but that's not to say that we won't be looking at in the future. I mean, Pablo's just mentioned about a few of the things that we are looking at, but obviously we are going to add to that as this product grows and develops and matures. Finally, so steam turbines. Steam turbines is going to be one of our key target markets for the Defiant product, and this has been a real driver for us to make sure that we are API 612, API 670, ISO 10437. We are now, this is now classed as a protection system, so we are in that bracket of less than 40 milliseconds response time. We're getting around 10-15 milliseconds. So we are now in that bracket to be an overspeed detection device. What are we going to be monitoring from that? We're going to be monitoring prox probes, proximity probes. We're going to be creating orbits. We're going to be doing center lines. We can use key phasers, and we can get a lot more measurements from a turbine.
And Ollie, if you don't mind, I'd just like to add to that a little bit from a turbine monitoring perspective, especially considering the fact that that's the world that I come from. If we think about, turbine monitoring and the cost of turbine monitoring and the cost of protection systems on the market, Those protection systems are typically quite expensive. They are manufactured by the turbine manufacturers or other third parties. And the analytical suites associated with them, and I won't go into the names of each of them, but System 1 might be one. Those are quite expensive. So if we think about what Defiant really, the use case for turbines in particular, gas turbines and steam turbines, this system can piggyback quite easily off of an existing proximity probe based system like a Bentley Nevada 7200 or 3300 series probe system. I just wanted to add that.
No, exactly, David. So yeah, piggybacking off existing systems, whether it be on that, it doesn't necessarily have to be on turbines. We can piggyback off existing systems if they are in place. But one of the things, or a few of the points that I've got for turbines, that this could be used as a commissioning device now, because we're doing that continuous monitoring. We can be doing performance testing. We can be doing thermal running. We can be doing turning gear monitoring as well. All of those things we couldn't really offer that before, but now the new Defiant product will be able to get us in with that crowd. A few other things that I really wanted to mention. Some of the hardest machines to monitor. So one of the another approach for the Defiant is really to start tackling these difficult, hard use cases that are just generally a bit of a pain. So slow speed monitoring, Pablo briefly mentioned about ultrasound. Ultrasound acoustic emissions is something that we've added. Reciprocating compressors, engines. So now that we've got that live time domain and waveform analysis combined with phase across 16 channels, that will make that process a lot easier and a lot faster. Planetary gearboxes, order analysis, sideband detection, we're going to be doing that. CNCs, machines and robots. So CNCs and robots are generally a bit of a pain because they may operate infrequently or for a couple of seconds and then turn off again. But now that we've got this continuous monitoring and this live system, we can now trigger the vibration and trigger the recordings, but not to forget that we can also use our digital inputs, our discrete voltage sensors to get things like force and torque. So now we can really get a full picture of what's going on with these machines. Force and torque being the interesting ones for me. High temperature applications. So we've had some challenges in the past with Phantom because that is a plastic product and it is constrained by a battery. Batteries can only go up to a certain temperature. So now that we've gone to hardwired, we can start using high temperature accelerometers. We can also use things like infrared pyrometers. I don't know if anyone's doing anything on kilns, furnaces or boilers where we're measuring internal temperatures with something like that. We can use 4 to 20 milliamps with pyrometers. Large structure systems, buildings, dams, bridges, using specialist sensors that are on the market. We can record these together and create instantaneous recording all in one place to understand how something's moving. That's not to forget that obviously because we're recording all of these with the Defiant, you could then produce an ODS with that because they are all simultaneous. So that's just to name a few of the things that we can do with this product. That's back to you, Mike.
All right. Well, let me share my screen again.
Just before you carry on, Mike, sorry, I couldn't see the chat just when I was talking then. Let me just rattle off a few of these questions real quick. So A&L files, WAV. So
I already answered that one.
Okay. It seems like you're already on it.
Yeah. So, all right,
Sorry.
moving forward, let's get through Ollie's. So really, at the end of the day, what's it really come down to, everyone? If you scan this QR code, that's going to connect you to our Contact Us form and our global network of distributors around the world. So if you're interested in Defiant, please scan the QR code. It'll bring you directly to our Contact Us form. You can select the drop-down Defiant, and we will make sure that the appropriate person gets in touch with you ASAP. This is where it gets very interesting, everyone. Defiant is truly defying the rules of the market because of all of its capabilities, but also, very importantly, the cost. If we think about competitive systems on the market for continuous monitoring and protection, those devices are typically quite expensive and have annual maintenance agreements and various other costs associated with them. We at Erbessd Instruments continue to innovate and continue to take on the precipice of being the leader in effective. I got to turn my volume down, sorry. We continue to focus on being the effective and most, there we go, effective and the most cost-effective product on the market. So when we release a product, whether it be Phantom or in this case Defiant, our goal is to bring a product to market that, as Dr. Erbessd, our founder and president, has so eloquently put it, I want to make condition monitoring easy and affordable. Well, that is the premise of what we do here at Erbessd Instruments, and I hope that everyone here has learned something new today about Defiant, about its capabilities, about its defying characteristics in the market, and most importantly, consider being an early adopter of this amazing technology. Just to answer a few questions, the full class will, the master class will be available recorded on YouTube for future review, and that will be in both English and Spanish. So with that, I will open it up to any comments in the chat to see if there's any other questions. Oh yeah, so that's actually a really good application that Oliver didn't cover, but one of the things that Defiant was designed for beyond turbine monitoring and critical applications was mobile equipment. Mobile equipment presents a very unique challenge when we talk about monitoring. And with Gateway 2, we were able to achieve mobile equipment monitoring with the onboard storage and wireless sensors. However, the monitoring was not continuous because it was wireless. With the Defiant, we will be able to incorporate both wired and wireless inputs and monitor continuously off those wired inputs for the critical elements of a piece of mobile equipment, like a drag line within the mining industry or a haul truck within the mining industry. So those are two very unique applications that Defiant was designed to specifically fill as well. Are there any other questions, Nicole? Absolutely. So if anybody else has any questions, feel free to scan that QR code, connect with us, and we'll be sure to get you that information as soon as possible. As always, we can be reached very easily by dialing 1-877-223-4606. That's our international toll-free number. You can visit us online at www.erbessd-instruments.com, and we'll look forward to hearing from you soon. And thank you for joining the masterclass and welcoming Defiant to the market. We truly appreciate your support. Thank you, everyone. Have a great day, have a safe day, and we'll look forward to hearing from you soon.